Section 2.4, Summarizing Categorical Distributions. So the concepts of shape, center, and spread that we used in the prior sections to summarize numerical distributions sometimes don't make sense for categorical distributions. And the reason is we can often order the categories any way we please. So if we were to reorder them, one ordering might look like it is skewed right. If we put them in reverse order, then it would look skewed left. We could reverse move them again. So it can really change the way that the distribution looks. So sometimes we can't use those. We can still talk about typical outcomes though, like the center and the variability. Just a reminder, mode is the category that occurs most often, and it should be the tallest bar in a bar graph. There is some difference between numerical and categorical modes. For numerical, you can have multiple modes, which we've seen before. Sorry, I can't spell right now. They can have multiple modes that are not close in value. So for instance, numerical, we could have something that went like this, and we could call both of these modes, even though they are not close in value. However, in categorical variables, you are only going to have multiple modes if they are tied or nearly tied in value. So these would have to be pretty much exactly the same in order to both be considered modes. Our concept of variability also changes a little bit when we're thinking about categorical distributions rather than numerical. When you're thinking of variability with categories, you want to think of the word diversity. How diverse are your categories that you're seeing? High variability means you have a lot of diversity, you have a lot of observations spread across many different categories. You may have several modes or categories that are at least close contenders for being the mode. And low variability would mean low diversity. Most of your observations are in a single category. There's one clear mode with no others even close. Okay, let's look at a few distributions then, and let's comment on the variability and the mode in these. So the first one, we have days of snow in 4 different months here. Categories across the bottom are our months, and then we have our frequencies of our days of snow. Looking at this one, first glance, I would probably say there is one very clear mode here of February. 14 days is much, much higher than the next contender, 6. So we do have one clear mode. And we do not have very many categories. We only have 4 categories that have any observations in them. So few categories with one clear mode. If we look back up here, what that would lead me to is this is a low variability situation. Okay, if we look at our next example here, we have birthdays of students by month. So we've got the months across the bottom and the number of students who have a birthday in that month up the side. Now, the first thing I notice here is that I have a lot more categories, and not only do I just have more categories, I have observations that fall in all of those categories. So I have many categories that have outcomes in them. So it wouldn't matter if I had all of the months listed, but I had only birthdays in May, June, and July, then that would still put me in like a few category situation. So I do have many categories that have outcomes in them. And what I'm seeing here is that I do have one mode that is higher than the rest, and that would be June, but it's not quite as by far like the one above. It's not quite as easy of a win because we have ones that are very close. We have May has 8, October has 8, December has 7. So even though I do have one mode, I have other contenders for the mode. So when I put that into words here, So if I think of those together, it actually puts me, this is more of a high variability situation. Okay, so those two seem fairly clear, I think. And then, of course, I had to add kind of a unique one in here. So on this one, what we've got across the bottom is we have the different numbers you could get if you roll a die. So if you roll a die, you could either get a 1, 2, 3, 4, 5, or 6 on that roll. And what we have up the side, this is a relative frequency histogram, or bar graph here, I guess. It's more of a bar graph. These are categories. There technically are some spaces in between here, even though they're small. So this is a bar graph, but it is a relative frequency bar graph because we've got percentages up this side. So what we're seeing here is if you were to roll a die 50,000 times. So this was clearly made by a computer simulation. But if you were to roll a die 50,000 times, these are the percentage of times that you would roll a 1, a 2, a 3, a 4, a 5, and a 6 in some experiment that they did. So what we see is really it's pretty level. You're just as likely to roll any of the numbers here. Okay, so let's think about our categories here. We want to talk about what's the mode. And honestly here, it's very, very hard to tell. It looks like the very highest bar might be the 4, but by just barely. I think every single value here is a contender for the mode. So all of the values are contenders for the mode. And as far as the categories that we have, well, we have every possible category. It has some representation here. There are only 6 possible things you could get when you roll a die, and all of them are represented here. So if I think back, what we have here, we have all of our categories having outcomes in them and all values being contenders for the mode. So if we look back into our situations here, this would definitely be a high variability situation.